You can proceed to the next slide. Thank you, thank you. So the next step is actually to demonstrate, or rather to give a short demonstration on what we have been able to do um, up to now. So you can think I can share the screen. Allow me to share the screen so that yes. Thank you so much. Um, okay. Just a minute to share the screen. Yeah. So yeah. So thank you. I hope um, can be able to see my screen. Maybe you can just maybe on the chat say yes if you can be able to see the screen.
Yes.
Okay, thank you, Pooja. So let me just proceed on. Now, I'm not going to go into the detail of the code. I'm just going to run it so that I show you some of the data set that we are, rather the some of the results that we are able to see. Now, as you can see, this is Google App Engine Python, JavaScript API, which is the default API. So let me run the code. I think it's running. Yeah. Okay. Um, okay. It's taking quite some time to run, but yes. So as you can see, this is Nairobi. Or rather, this is Sentinel-2 image processed and masked to Nairobi County. So this visualization is band 12.5.2, which is actually also an extension of false color composite visualization. Now from this part, I can be able to zoom into the river so that we see which part of the river that we are very much interested in. Um, okay. My internet is quite slow. Okay. Yeah, so this is the river as it is loading. Um, you see it's flowing from the upper region of Nairobi, the western region. Um, yeah, all the way to um, the lower side of the Nairobi, where it's moving on to Ruai, then exiting Nairobi County. So the reason why we also set to choose on Nairobi as our region of interest is because of so many anthropogenic activities that are actually taking place in Nairobi. You realize that it's a city, for instance, with so many industries. So, and those are the um, key, rather, those are the areas that influence so much to the river. The population pressure also, as you can see now, these areas are just developed areas. So along the river, you see there's a lot of developments along the river, all the way to Ruai and as it exits Nairobi. So that is the first part. So this is Sentinel-2 processed and clipped to our region of interest. And then now the next one is the modified normalized difference water index. You'll bear with me. My internet is quite slow, um, but I hope you can be able to see.
Yes, yes, we
Um,
can see.
yeah. So we're using this index that is normalized, modified normalized difference water index to be able to mask out land areas so that we will not remain with the river section. Um, for more information, we will also be providing the documentation on the same. And then now the next one is now after that we perform the mask. So that is the water extracted. Now, unfortunately, we are experiencing issues with technical. Basically, from the remote sensing side, we realize that Sentinel-2 is quite having coarse resolution in terms of spatial resolution. That is. So we are trying to improve our masking so that we capture at least most of the part of the river. As you can see here, we are unable to capture most of it, but we are making improvement on it. So you realize that we need to remain only with the river section. And then now the next one is the process. We also try to do morphological operation on the river so that at least uh, becomes more clear. And then now we have the population um, plotted. Now this is population distribution around Nairobi, in Nairobi County, that is, or in the Nairobi city. As you realize, along the river, this river, let me change the opacity of this one so that you can see how. Let me okay, change the opacity a little bit. Okay, have, I can even maybe increase it a little bit somewhere there. Hope. Yeah, I'm trying to visualize both of the layers so that you can see. Um, okay, it's loading. Okay. Yeah, as you can see, along around central region of Nairobi, the population is way much too high. So, and that is the key part, or rather, the key area that we are interested in because of the population increase, and then most definitely is going to influence the river. And then you realize that there is a lot of informal settlements along the river, which is not organized, and therefore they are going to have a very negative impact to the river. And then that is the industry data. We happen to go those, but we're hoping that we get more industry data so that we can be able to get the proximity of these industries and probably also be able to quantify in terms of maybe the effluents they are releasing to the river and maybe how they are managing so that we can be able at least to quantify and assess. Yeah, so that is the demonstration. Um, uh, it's brief, but we're also improving on it. So Nicholas, back to the presentation.
Okay, so thank you very much, Michael, for that. I wish we could now go back to our presentation.
Yeah, okay, let me stop sharing.
Yes, please.
There, it's okay now.
All right. Should be coming up. All right. So this part now is Roger, who is going to explain for us the front-end dashboard, how we are going to expect it to look like. Roger, over to you.
Thank you so much. Today I come to you not as a UNAP colleague, but I'm part of this community. And so just a quick primer. When this team came up and desired interest, I was happy to jump in. We've only shared the Nicholas, the presentation went away, so if you could kindly share again, that'll be great. We only started on this project a couple of weeks ago, and I think the objective is really just to share where we are. I see a lot of interesting questions come up um, based on what Nicholas mentioned, and Michael and Christopher as well. We wanted to just draw up. This by no means is, final. We are still looking for front-end developers. So if you are a front-end developer, part of the community, please reach out. All the details will be there later. But this gives you a taste on what it could look like. So the map that you see there, it's a little bit hazy on my screen, but really what we're trying to do is, like Michael mentioned, really clip down to the river, identify the factories, the large factories by, let's say, size and proximity, and then also look at the type of industry they belong to, because each of those have different types of chemicals, and of course the population. There are lots of challenges still that we need to address, and there's a slide later on that. But what you can see is a little bit of a geospatial map, sort of correlating the river with population and industry or factory hotspots. So as a user, what you could do is on the top right, you could choose any administration ward, whether it's Kibera, Dandora, Dagoretti. And then based on your selection, here we have Kibera. So you could see the water quality parameters that our colleagues mentioned. And then you could also see the factories in that area. You could see the square meters, you could see the industry that they belong to, and also then the population density. That in a way is sort of a bit of a dashboard that we're aiming for. What we're also trying to do is bring about some friendly competition between these administration wards. So we are still trying to figure out the methodology on how we could arrive at some sort of ranking. If you've worked on this before, please give us a shout. But our hope was to come up with some sort of scoring on which wards have the most polluted water. So policymakers, ward administrators are inspired to take action. And then we wanted to also link to related resources, whether it's sanitation, wastewater management, treatment of factory waste, those kind of things. So in a nutshell, this is what it could look like. There's a lot of improvement to make, but just a little taste. And Nicholas, if you could go to the next slide, please. And I think I mentioned this already. What we found in our few weeks of exploration is at some points, what we wanted to do is capture a full view of the river. But we noticed that the Nairobi River at some places, crawls to a very small width. And so geospatial cannot really optimally capture that. So we went down to the ward level, and we are playing with specific points at the ward level. We are also, like cloud cover, getting high resolution data is a bit of a challenge. So we are weeding through that. So if you're a geospatial scientist, a geospatial expert who's worked on this before, we'd love your help. And we know the situation in Nairobi. There are lots of illegal factories. They're not even registered in our data sets, right? So how do we account for those? And I think one of the big pieces is arguably most of these pollution hotspots are informal settlements, right? Which may not even reflect accurate population data, which is currently being pulled from census annually. So these are, in a nutshell, some of the challenges. But our hope was just to give you a little taste and share this with the broader community. So those of you who are interested in this open source project can jump in to contribute. And I will pass it back to Nick to just share a little bit about where the repo and other details can be found, and then we can do a quick round of Q&A and close the session. Back to you, Nick.
Sorry. Thank you very much, Roger, for that great presentation. It is really nice to have you here and the great entire open source community. So just very fast, I'm going to show you where you can find our GitHub repo for the repository and also the Gmail account for us, whereby you can reach to us. So if you follow this link, you'll be able to get to our repository, and which will be able to, from there you can work with us in that project. Then should there be any clarification you are looking forward to, this email is open to us. One of us could be able is accessing this link Gmail, so you can get an answer or any clarification you will be looking into. Then after this, we are just going direct to question and answer sessions, whereby we are looking forward to hearing from you, your comment, your recommendations, any clarification you might wish to say to us. You are open to this session. So, but this point time, I'm going to welcome Pohoja, who is going to moderate the Q&A sessions for more clarification. Welcome, Pohoja, for this session.
Thank you so much, Nick. May I ask you, Michael and Christopher, to please turn on your videos so folks can see you. I already have a few questions in the chat, so I could start with those. Victor Nyagudi asks, where can we find the previous recorded sessions? Nick, would you be able to answer that?
Yes, I can be able to answer this. Okay, so thank you very much for that question. I would say that we have had some of the recordings which we have done for the previous sessions, but we haven't uploaded them to our YouTube channel because they weren't of the good quality. So also this calls for any video editor. You can join us to help us in editing the previous recordings so that we can get to upload them. But we have a YouTube channel. We have everything set, and but if you would love to see them without being edited, still okay, we can share with you. Right. Thank you.
Thanks, Nick. So the next question is from Emad. Emad asks, can you share the script in the chat box? Nick, will the work in progress be found in the Git repo, or can it be shared in the chat box?
Yes, now that we have shared the the GitHub repository, all this code will be available in the repository. So you need just to follow us in the repository and you'll be able to access everything in that GitHub repo for the community. Thank you.
So the next question is from Kakuko. Kakuko, thank you so much for joining. Kakuko is the UNEP lead for all the pollution work. She has a question on water quality parameters that you will monitor. This may be more for Michael. Since it is using Sentinel, it only can cover those like turbidity, algae bloom, vegetable growth like water hyacinth, correct? How is the ground truthing planned? So maybe Michael, you could come on and share a little bit about your decisioning, how you were looking at Planet and Sentinel, and why you decided to go with Sentinel and why only those. Is there a plan to include more parameters?
Okay. Yeah. So. Okay. Yeah. So. Okay. I hope you can hear me, right? Yeah. So the reason why we chose to settle on those few parameters is because, first of all, there is already existing algorithms or equations that we can be able to use so that we model those specific water quality parameters. And then also, you realize it because we are working with Sentinel-2, though we are not so sure if it's going to be very, very effective because of the spatial resolution, which is caused, in this case, it has got actually an advantage because of its higher spectral resolution, that is in terms of bands. We can be able to compute those water quality parameters if we had settled on those few water quality parameter studies. Yes. Yes. Thank you.
Thank you, Michael. I think Kakuko has an interesting comment and insight. She led the project for countermeasure in Asia, which tracks pollution hotspots along many of Asia's rivers. And she said, based on UNEP's experience in Asia doing river basin plastic leakage monitoring analysis, tracking using satellite image as data source is not enough due to low resolution, and data updating is not frequent or focused enough. Supplementing the analysis with other imageries is necessary. We found it necessary to automate the image analysis with AI as much as